So here's a fun problem. The statement reads, we obtain the potential of a spherical shell with surface charge sigma equal k cosine theta. We found that the field is a pure dipole outside. It's uniform inside. Show that the limit as r goes to 0 reproduces the delta function term that we just found. Alright, so to start, we need to show that the field inside the sphere approaches a delta function with the right coefficient in the limit as r goes to 0. We know from the previous exercise that the potential inside is given, where v is equal to k over 3 epsilon naught r cosine theta. We know that r cosine theta, however, is the polar representation of z. So we substitute that in order to take the gradient, which we know we'll need to in order to find the electric field, which is done to the right. We also know from a previous problem that the dipole moment of the configuration is P equal 4 pi r cubed k over 3 z hat. Note that the electric field that we just found and the dipole moment both have a factor of kz hat. So we solved the dipole moment equation for kz hat in order to substitute into the electric field, so we can write the electric field as a function of the dipole moment, which we do here. We can clearly see that E goes to infinity as r goes to 0 if P is held constant. So its volume integral, remember divergence theorem, would therefore yield the E field times the volume of a sphere, which is 4 over 3 pi r cubed, and so that cancels the 4 pi and the r cubed out, leaving you with negative P over 3 epsilon naught. Just so happens this matches the delta function term, and we verify the result from the previous problem.